Hey, fifth graders. All right, so we have some more algebra to do. This one is inequalities. This is kind of a weird lesson, I'm not gonna lie. Basically, it's going to give you problems where you can have a number of answers that could potentially be correct. Sometimes there'll only be one answer that's correct, but other times there's going to be a lot of them. And really what it is it's these symbols that you guys have all seen, right? So less than, greater than, and now here's two new ones that you have not seen. You've got less than with a line under it and greater than with a line under it. And all this means is that it is less than or equal to some number. So if I give you D, right? So just some random number, I'm going to take this off for now. I say D is less than or equal to 4. All right. And I ask you, what could D be? Well, D could be a lot of things, right? Especially if I say that it's a whole number. So what whole numbers are less than or equal to 4 and greater than 0? We'll assume that we're stopping at 0. All right, well, it could be, so D could equal, it could equal 4, right? Because that's equal to 4. It could also equal 3, because 3 is less than 4. It could equal 2, because 2 is less than 4. It could equal 1, or it could equal 0, right? Any of those are possible, and that's okay for this problem. I know in math, a lot of times we want just that one solid answer, but we don't always have just one solid answer. Sometimes we say, hey, it could be anything in this range, okay? So let's take a look. I'm not going to worry about their unlock. Well, actually, let's do unlocking the problem. That probably is the best way to start. So every morning, Bobby's Hot Bagels makes a special claim. All bagels Bobby sells will be warm and less than 9 minutes old. What inequality can you write to represent in whole numbers how old Bobby's bagels are? So, and then we can use the less than, greater than, or the ones that are equal to, okay? So first of all, we want to write the inequality in words. So they have time is less than nine. Okay? So because he says that they will be warm and less than 9 minutes old. That means they can't be 9 minutes old. They can only be less than 9 minutes old. So if you're going to write this, we would say T for time. It's just terrible writing. T for time is less than 9 minutes. And then we would come up with all of the possible answers, which, of course, if you're looking at this, they say out of 3, 6, 9, or 12, which numbers are solution to T? So if we have 3, 6, 9, and 12, which numbers can we plug into T and have that be true? Well, 12 is not less than 9, so that doesn't work. 9 is not less than 9, it's equal to 9, but this is less than. It has to be fewer, like his bagels, 9 minutes, and, or I'm sorry, 8 minutes and 59 seconds. He promises that they will be at least that old or younger, basically. Okay, once they hit that 9 minute mark, he's got to throw them away or something. So yeah, so this one doesn't work and this one doesn't work, which means that T could equal either 3 or 6. Okay, so when you wrote that, you would just write 3 or C equals 3, 6, or 3 or 6. All right. They also, and if you were reading through it really carefully, they also kind of throw another thing at you that we haven't really talked about a whole lot. This symbol here, really that just means does not equal or not equal to, okay? It's not going to come up, I don't think, in the rest of the packet. It's just this one time that they threw it out there and they just never bothered to tell you what that meant, but that's what it means. The little equal sign with a line through it just means not equal to. Okay, so let's go ahead and go over some of these. Let's take a look at, we'll do 4 and 5. So first of all, you have to look up in the bold where it says we have 7, 10, and 13. Okay, and which of them are solutions to this? And then for number 4, we have B is less than or equal to 10. Okay, so we just want to know what things could be possibly equal. Well, on the line, you could just write it's 7, right? 7 is less than 10. Or it could be 10, because 10 is equal to 10, and this is less than or equal to 10. Okay, so that works. For number 5, we have C is less than 15. Well, which of these numbers, these 3 numbers here, are less than 15? Hopefully you all realize quite quickly that all of those numbers are less than 15. So you would just, on the line below, write 7, 10, and 13. Okay? Because all of those are valid answers to this inequality. So something that's an inequality, I guess maybe I should have talked about that, but something that's an inequality is basically a math problem that doesn't have an equal sign, okay? Because if it had an equal sign, then it would be an equality. If it's got something like this, then it's an inequality. It means it does not necessarily equal the number at the end. So if we had, like, I don't know, we're done with these. Let's say that we had 7 plus 8 is less than 20, right? We would say that this is an inequality, right? Because 7 plus 8 is 15, and 15 is less than 20. So it's a true math sentence. It just doesn't happen to have an equal sign, which you guys have not really seen before, and for whatever reason, they didn't bother to explain it super well, or maybe I just failed to explain it very well, but that's okay. So this sort of thing is an inequality. It just means that it doesn't have an equal sign. Okay, so let's do, oh boy, let's do the number line one. So this will be number 9. So it says in is, and for whatever reason, a lot of the ones that I picked are the less than. Obviously, it could go the other way if it was greater than. But n is less than or equal to 6. And then they give you a number line. And they want you to show 2 solutions for the inequality on a number line. Okay? Well, let's say this is 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, good enough. All right. Well, I'm going to show you all of the possible solutions because it's pretty easy, right? So n is equal to 6. It's less than or equal to, but it could be 6. That would still work. And then all the numbers going this way, they all work, right? Because all of them are less than 6. So 5 is less than 6, 4, 3, 2, 1, and 0, all less than 6. So just, I guess, put circles or something to make it clear. And you only have to do 2. You don't have to do all of them. I'm just doing all of them to show you what it could be. But really, anything on that number line that is below, if it is 6 or below, is a valid answer to that problem. Okay, number 10 is kind of similar. It's just anything bigger than 2. Let's do number 11. Okay, so number 11 says, for her birthday, Dinah wants to invite at least 8 guests, but not more than 12. So how many guests might she have? Name all the possibilities. So this is kind of a weird one. So we're going to use G for guests, right? So she wants at least 8, which means that G is going to be greater than or equal to 8, okay? So that's that. But she wants it to have no more than 12, which means that G is less than or equal to 12, okay? So G has to fall somewhere in this range. And if we were going to do a number line, which you definitely don't have to, right? I'm going to say 7, 8, 9. Oops, I probably could have spaced those out a little bit. Let's do this better. Something like that. All right, 7, 8, 9, 10, 11, 12. Okay, so G is greater than or equal to 8. So it could be 8, right? And then it could be anything going this way for this part of the problem. For this part of the problem, G is less than or equal to 12, so it could be 12. And then from there, it's just everything in between. Now, since we're talking guests, we have to do whole numbers, right? You can't have 2/3 of a guest. That would be gross. But G is going to be one of these numbers, right? She could have 12, 11, 10, 9, or 8 guests. It would work out for what it is that she wants for her birthday. And what Dina wants for her birthday, Dina gets. So, yeah, that's it for lesson 14, which also is it for this grouping up to the checkpoint. So good luck. This is your 3rd checkpoint, and there's only like 6 more lessons for the 6th grade packet. So there's 15 through 20, and then you can take the last test and be done. Anyway, I hope you enjoyed this, and or at least I hope it made sense. I don't know if you necessarily enjoyed it, but I hope it made sense. If you have any questions, as always, feel free to let me know. Have a good day.